आपका स्वागत करता हूं ये सीवी लर्निंग में। तो आज हम देखेंगे व्हाट आर प्रॉपर्टीज ऑफ सेट्स। complement of sets. Set complement will be required only for set. Now what is complement of set A? Suppose you are having some set A, a subset of universal set U. That times complement of set A is nothing but all those elements that are in U, means from your universal set, but that element must not be in A, means apart from A all element you will consider in your A dash, in complement. Okay, now I will dictate here A complement is nothing but, suppose A is any subset of universal set U. Okay, now A is any subset of universal set U, then A complement is given by the set containing all elements of U. Okay, my A is subset of U. I will contain all elements of U that are not in A. Note this, not in A means what I will take? I will take all those elements of U that are not in A, and it is denoted by A dash. Okay, this is the symbol of A complement. It is इसको कैसे हम रीड करते हैं? A complement. Now what it will be? A complement will be all those elements that are from U, but your X must not be in A. Okay, means you will take all elements of U and X must not be in A. Means what this definition says? I don't remember what this definition is. X belong to U and X not belong to A. This is nothing but U minus A. Means my A complement will be U minus A. All elements of U that are not in A. Okay. Now here I will take our Venn diagram as, suppose this is my Venn diagram. Okay, this is my U set and this is my some A set. Okay, this is my A set. Now what your definition says? Your A dash is nothing but all elements from U that are not in A. Means A में जो भी element आएंगे वो हम consider नहीं करेंगे, बाकी के सभी universe के elements consider करेंगे. मतलब ये सारे elements मुझे A complement में दिख रहे हैं, but I will not consider the elements from A. Okay, this has become your A complement. Means this all are nothing but your A complement. That you can observe here. What this is nothing but U minus A. Ignoring A, you are considering your all elements in A complement. Means this has become your U minus A. Okay, this is your A complement set. Okay. Now we will take some example on this and we will verify whether this is true complement set. What is complement set in Venn diagrams? Now suppose I am having some universal set as U as my rationals, okay, set of rational numbers, and then I will take some A as set of whole numbers. Okay, my whole numbers. You know this. My whole number is subset of rational numbers. Okay, means my A is subset of B. Now I want my A dash. Okay, A dash means I will consider all those elements, okay, that are from U, but and that X must not be in my A. Okay, what this means? All those elements X such that X belong to U. U is nothing but your rational numbers. Means I will take all rational numbers and that rational numbers must not be whole numbers. Okay, means what this will be? This will be nothing but your the set all X rational numbers that are not whole numbers, means that are P by Q. X equal to P by Q. PQ belongs to Z, but X will not belongs to W. Means you will take all the integers that are not whole numbers. Means you will ignore the whole numbers. Means what? You will not take 0, 1, 2, 3. Excepting these elements, you will take in your A complement. We will see it by Venn diagram. Means suppose here this is U, this is your U, and I am having my A as my whole set. Now what will be my A complement? It will be this. What it will be? This will be all remaining elements that are not in my this A. Okay? This is my A complement. This is nothing but all the rationals that are not whole numbers. Means excepting 0, 1, 2, 3 and so on, other irrational numbers are nothing but my A complement. Okay? This was your example of a complement of set. Okay? Now we will just quickly see some standard elements or standard sets complement. Okay? We will consider some properties of complement here. Okay? Just quickly हम अभी देख लेंगे what are properties of my complement of set. Okay? For this I will take first properties. First property. Properties of complement of set. Okay? Now first property is what is A union A dash. Okay? What is A union A dash? Where okay, for this I will take my A from some universal set, subset of universal set U. For complement I will must require my U universal set. Okay? What this is? Okay? That I will calculate now. My A union A dash. What it is? By Venn diagram you can see this. Okay? Suppose this is my U and this is my A. Okay? Then I will take my A dash here. Okay? This is U and what will be my A dash? My A dash will be this. Okay? This will be my A dash definitely. Okay? This is my A dash, this is A. Now what I will take? I will take union of them. Okay? What its union will be? That we will see here. Means your union, now here it is A is nothing but all these things. Okay? What your union consists? Union consists all those elements X such that X belong to A or X belong to A dash. Means you will take X belong to either from A or X belong to A dash. Now first I will take X belong to A. Means this is my X belong to A. This is my A. Or X must be from A dash or A dash. Means your element must be from A or A dash. I will take A dash also. Now this is my A dash, the remaining set. Okay? This is my A dash. What this has become? This has nothing but your whole entire U. Right? You have considered A as well as A dash, means it has become your U set. Okay? Means A union A dash will be your U. That you can easily say, na? Easily see, na? But A consists elements from A and A dash is nothing but the elements that are not in A. Okay? But that have way of calling A. Means it has become whole universal set. Means A union A dash is your U set. Okay? This will be your whole U. Okay? Means A union A dash is your whole U set. Now what next? Okay? Now we have calculated A union A dash. Now I will calculate my A intersection A dash. Means what? I will take all elements of A and that elements from A dash as well. Means elements of A and elements of A dash. But I am not having any element common to A and A dash. Since my A dash consists those elements that are not in A, means A and A dash will have no common element. Means A intersection and A dash will become 5. Definitely. Means that is nothing but your second property. Now I will go to third property. What is my complement of A dash? Okay? I am taking complement of A dash. What it will be? It will be by definition, it will be nothing but all elements of X. Okay? Elements of X such that X belongs to U and X belongs to A dash. Okay? And I am saying X does not belong, sorry. X does not belong to A dash. Means you will take all elements of U that are not in A dash. Okay? What this is? This is nothing but X such that X belong to U. Okay? X belong to U. And what is X does not belong to A dash? Means your x does not belongs to, what is your a dash, that we have taken it as u minus a. Okay, means you will take all elements that are from u and x does not belong to u minus a, means कौन से एलिमेंट आ रहे हैं यहाँ पे अभी हमारे, means you will take all elements of u and x does not belong to u minus a. What this means, x says that x belongs to u and now x does not belong to u minus a means what, x belongs to a, right? Does not belong to u minus a means what, you will have your x will not belong to u minus a. Okay, or for example I will write here, suppose this is my a, okay, this is my a and this is my u minus a. Okay, since this is my u, this is a, this is my u minus a. What I am telling is x from u, okay, x from u such that x must be not in u minus a, मतलब x u minus a में नहीं होना चाहिए. आपका x u minus a में नहीं होना चाहिए मतलब क्या होना चाहिए, x belong to a होना चाहिए, right? x belong to a. But what this is property, x belong to u and x belong to a means it is nothing but x belong to a only. Your x such that x belong to a only, मतलब हमारा a और u में कॉमन क्या होता है, जस्ट a ही होता है, तो वो दिस इज नथिंग बट a, means a complement a dash has become my again a, what it is nothing but a complement of a dash has become a, means complement is again idempotent. Okay, this was about complement. Now I will consider complement of next set. Okay, it is, what will be complement of next set, I will take complement of third property, complement of phi dash. Okay, means I will take complement of phi. What it will be, all x belong to u such that x belong to u such that x does not belong to phi. Means what, you will consider all those elements that are not in phi but in u. But what is element in u? Phi. There is no element in phi, means you will consider it as x belong to u only. Means since there is no element in phi, therefore it is मतलब ये लिखना कुछ हमारा वैल्यू नहीं है, मतलब x does not belong to u, phi में कुछ होता ही नहीं है तो does not belong to लिखने का कुछ मतलब ही नहीं, मतलब x belong to u ही आ गया, it is nothing but u, means your phi complement has become your universal set, hold u. Okay, now next is fourth property, what is my u complement. Okay, u complement is nothing but all x belong to u such that x does not belong to u. Okay, मतलब आपको वैसे एलिमेंट लेने हैं u के जो u में नहीं होने चाहिए, तो कौन सा एलिमेंट होगा, ऐसा कुछ एलिमेंट होगा ही नहीं, राइट? मतलब यहाँ पे क्या मिलेगा आपको, empty set, मतलब एलिमेंट ऑफ u that are not in u. Not in u means what, आपको कौन सा एलिमेंट मिलेगा ही नहीं, u में से नहीं, u is nothing but biggest set of your all other sets. Okay, universal set contains all other sets, means u complement will contain empty set. Okay, that we can define it as, here it is your u and its complement will become phi. This will be your, this implies u complement is equal to phi, means आप इसके बाहर आपको कुछ मिलेगा ही नहीं तो वो रहेगा आपका phi. u complement is nothing but phi. This was property of complement with universal set and your set empty set. Okay, the property, the last but not the least of like this, A union B complement. What will be my A union B complement? Now it will be again become A complement intersection B complement. Okay, means what I will take? I will take union of complement of union is nothing but intersection of complement. Okay, what it is? This is nothing but your De Morgan's law. Okay, this is called as De Morgan's law. Means A union B complement is nothing but A complement intersection B complement. Again, what is my A intersection B complement? It will be nothing but A dash union B dash. Okay, this is also called as De Morgan's law. Means complement of intersection is nothing but union of complements. Okay, what I am write here in words, complements of union of of two sets is intersection of complement of sets, right? Means complements of union, right? Complement of union is nothing but intersection of complement. Okay, means you are changing your operation union as intersection and you are taking separate complements. Okay, next thing is nothing but complement of intersection, right? Intersection is union now, union of complement. Okay, now this is also called as your De Morgan's law. Means you will take complement of intersection as union of complements. Okay, this has nothing but your De Morgan's law. This is very important property of complements. Okay, now after that, what I will say, this was all about your universal complement set. Now what is next thing? We will take some examples such that we will be comfortable with this De Morgan's law. Okay. Now suppose I am considering one example for this De Morgan's law. We will verify by using some example. Okay. Now I am taking my example as, I will take universal set as 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. Okay. For this I will take my A as A equals to 1, 3, 5, 6, 8, 10. Okay. Now my B will be 2, 4, 7, 2, 4, 7, like this only. Okay. I can take A and B as 2, 4, 7 and 1, 3, 5, 6, 2, 4, 1, 3, 5, 7, sorry, 7, I must contain 5, 6 and 7. Okay, 2, 4, 5, 6 and 7. This is my B. I am taking it as subsets of U only. A is subset of U and B is subset of U. Now first I will take A union B. What is my A union B? A union B is nothing but elements of A and elements of B. What are these? I will take first elements of A, 1, 5, 6, 8 and 10. Then I will take 2 since it is not there. Whether 4 is there, no, 4 is not there, 4, 5 is there, 6 is there, 7 is not there, therefore I will consider it. Means A and B is nothing but elements of A and elements of B, but not taking the common element twice. Now I will calculate A union B complement. Means I will take all elements from U that are not in A union B. Right? This is my complement, definition of complement. Now what are elements of U? Suppose 1 is there, but this is in A union B. Therefore I will not consider here. 2, yes, 2 is there, therefore I will not consider 2. 3, 3 is there, 3 is there, 4 is there, 5 is there, 6 is there, 7 is there, 8 is there, only 9 is not there. Okay? Therefore I will consider my A union B complement as, okay, this is A union B dash. Now we will calculate what is my A dash. Okay? For this I will require A. Here I will take A dash as all elements of U that are not in A. Okay, elements of U that are not in A. Now U 1 is there, but 1 is in A. Therefore I will not consider 1 here. 2 is there, but 2 is not in A. Therefore I will take 2 in A complement. Now what about 4, 3? 3 is there, but 3 is in B, A. Therefore I will not take in A complement. 4 is there, 4 is not there. Now 5 is there, 6 is there, 7 is not there, 8 is there, 9 is not there. Means this is my A complement. Now like this I will calculate my B complement. Nothing but elements of U that are not in B. 1 is there, now 2 is in B, therefore I will not take 2. 3 is there, 4 is there, therefore I will not take. 5 will not take, 6 will not take, 7 I will not take. I will take 8, 9 and I can take 10 also. Okay, this is my A complement and B complement. Now what I have to take? A complement intersection B complement. Okay, what it will be? A complement intersection B complement. Okay, this is nothing but elements of A dash and elements of B dash. Means common element of A dash and B dash. What are common elements? 2 is there but 2 is not here, 4 is not here, 7 is not there, 9 is in A dash, also 9 is in B dash, therefore I will take 9. Now come here, 1 is there but not in A dash, therefore 3, 8, 9 will not, 8 will not in A, it will not in A intersection, A complement intersection, B dash. 9 we have taken, 10 is not in A dash, therefore I will not consider A dash. Now my A dash intersection B dash has become singleton 9. My what? But singleton 9 is nothing but my A union B complement. What is this? This is nothing but A union B, its complement. Means complement of union of A and B is nothing but intersection of A dash and B dash. This validates your De Morgan's first law. Okay. Now we will go for second law of De Morgan's. Now what I will do? I will require A intersection B and then A intersection B dash. Okay. That I will calculate somewhere here. Okay. Now suppose here it is, I am calculating it as, okay, I will calculate here only. Okay, it is nothing but singleton 9 and I will take A intersection B. Okay, what A intersection B consists? Common element of A and B. Look at here, A is there, B is there. One is in A but one is not in B. Therefore, I will not take A intersection, one in A intersection B. 2, 3 is there but 3 is not in B. 5 is there, yes, 5 is there in A intersection B. Also, 6 is in both. Therefore, I will take 6. Now 7 is not there. Therefore, I will not consider. Means the singleton A intersection B dash has become 5 and 6. Then I will calculate my A intersection B and its dash. Okay, it is nothing but elements of U that are not in A intersection B. Elements in U that are not in A intersection B. Now A intersection B has 5 and 6. Therefore, I will just remove 5 and 6 from U. Other element I will consider here. 1, 2, 3, 4. I will not consider 5, 6. Then I will consider 7, 8, 9 and 10. This is my A intersection B complement. Excepting A intersection B, I am taking all elements of U. This has become my A intersection B complement. Now I will calculate A dash union B dash. Okay. What is my A dash union B dash? Here it is A dash and it is B dash. I will take its union. I will first take A dash. Okay. Then I will take B dash that are not common with A dash. Now 1 is there. 3 is not there. Yes, 3 I can take. 8 is there. Therefore I can add 8. I cannot add 9. Since 9 is already there, I can take 10. Now observe carefully here. What is my A dash union B dash? It is nothing but 2. Yes, it is there. 4. Yes, it is there. 7. Yes, it is there. 9. Yes, it is there. 1. Yes, 3. 8. And 10. Means my A dash union B dash has become A intersection B dash. Okay? Means this has become A intersection B dash. Means your A dash A intersection B dash is nothing but A dash union B dash. Means complement of intersection is nothing but union of complements. That validates your second law of De Morgan. Means actually this was all about your complement of A, the property complement of set A. This sums your whole topic set, chapter 1 set. Means we have seen all its definitions, its properties and examples of them. Okay. Now if you are having any problem with this video, you can comment this problem or any queries in our comment section, and don't forget to like, comment and subscribe this channel. Thank you.